facts. Number one, before starting the lesson, it is important to know the difference between the labels for the answers. What is the difference between feet, square feet, and cubic feet? So let's start off with a linear unit. When you see the word linear unit, I want you to think of, like, what do you hear? You hear a line. So a linear unit looks like a line, like this example here. When do we use linear unit? It's used to measure length or distance. Linear units, like a line, it's one-dimensional. So what are some examples of linear units? Measuring the length, the height of a person or an object, the width of geometric figures. Think about our room. Let's measure the length of our room, the height of the classroom, or how wide is the classroom. Also, in math, you've solved perimeter. Perimeter is the distance around a figure. So like if you were to add up all the sides, the answer would be a linear unit. You can take a piece of string and outline the perimeter of any figure, so that's a linear unit. What are labels for a linear unit? Units, just units. Inches, feet, yards, meters, centimeters, kilometers. That's it. Those are linear units. And here's an example of some linear units. The height of a tree, or the distance that this person's walking, I could measure by a string. Look at this cone. I could measure the height. It's a linear unit. The height of this ladder. What's a linear foot? Like a ruler. This is a linear unit. Hopefully that helps you. And you can picture a linear unit like a line, a string. If I look at this square unit example, we use a square unit to measure area. Square units are two-dimensional. If you look at the square, it has a length and width. It's a 2D figure, two-dimensional. When you think of area, think of a Post-it note or a tile. If you look at our classroom floor, you'll see tiles on the floor. One of those would be a square unit, okay? Actually, when I actually measured it, the side of one of the square tiles fits a ruler, so it's 1 foot by 1 foot. So each square tile in the classroom is 1 square foot. Now, so I'm measuring area. It's two-dimensional, and the labels for a square unit would be square units, square inches, square feet, square meters, square kilometers. And if you notice, the labels could be written abbreviated like square inches, SQ dot inches dot, or if you notice a little 2, this is called an exponent when it's in the upper right hand corner. Now it looks like you would read it as inches square, but it's not. You have to read the 2 first. It's square inches, square feet, square kilometers, square meters. So you can write it any of these ways. Now let's look at the example. Area is measured in square units. So you see this first, the 1 unit by 1 unit. What's 1 times 1? 1. And then because it's a square, unit times unit would be square units. Units to the second power, or 1 square unit. Now if I know that this equals 1 square unit, how many square units are in this rectangle? So if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, there are 12 square units in this rectangle. And honestly, a faster way would be you count, there's 4 across, 3 up, right? The length is 4, the height is, or the width is 3. 4 times 3 is 12. This has an area of 12 square units. And look at the example here. This blue square, it's a 3 by 3, 3 units by 3 units. 3 times 3 is 9. Units times units is units squared, or square units. Now, I did mention that area, you could think of a Post-it note. You could think how many Post-it notes would fit across? 12. Okay, and post-it notes cover area quickly. If I took a piece of string, would that help me find the area quickly? No. It would take a long time to figure out how many pieces of string would fit this, but a post-it note would fit quickly. Cubic feet. Cubic feet, if you look at the picture, it looks like a cube. So look at the difference between a square unit, it's a two-dimensional figure. Cubic foot is actually three-dimensional. Cubic unit is used to measure volume. Volume is the space inside a 3D figure. So if we're looking at our classroom, how much space would fill the inside of our classroom? Whereas area would be how much would be filling, let's say, the floor of our classroom. Okay, like linear unit would be if I were to take a piece of string to outline the classroom. Okay, so cubic unit, how much space can we fill inside? It's used to measure volume. It's 3D because you have length, width, and now height. So that makes it a 3D figure. A cube with a side length of 1 unit. So that's what a cubic unit is. That this is 1 unit by 1 unit by 1 unit. And again, think of a cube. So here are the labels for cubic units. You could write it out, cubic units, cu dot in units dot, or cubic inches. Now, because it's cubed, it means to the third power. And the reason why, because units times units times units means units to the third power. Or cubic inches. Cubic feet could be written like this, and again, the 3 goes to the upper right, but you still call it cubic feet, cubic centimeters, cubic kilometers. Now looking at this image, this is 1 cubic foot. Why is it 1 cubic foot? Because this is a foot, the length, width, and height are all feet, 1 foot. 1 times 1 is 1, 1 times 1 is 1, and feet to the third power. So 1 cubic feet. If you were to imagine the size of this, look at our tile floor. Imagine a cube that surrounds one of those tiles. That is 1 cubic foot. So hopefully that helps you think about the difference between linear unit, square unit, cubic unit. Again, linear unit, think of string. Square unit, think of post-it, or even like a tile. And then a cubic unit, just a cube. So linear would be like outlining the classroom floor. Or if you look at my back bulletin boards, the border that goes around it, that's a linear unit. Square unit, if I were to take post-it notes and fill completely or tile the whole floor. Cube unit, if I were to take boxes into the classroom to fill it up. What are polygons? A polygon is a closed shape figure with straight sides and angles. The word polygon comes from the Greek and means poly, which is many, angles, which is gone. So many angles. Now, what are characteristics of polygons? They have straight lines, so the edges have to be straight. It's a closed figure, it can't be slightly opened. There are angles, there has to be more than 2 sides, and no curves. So here are some drawings, examples of a polygon. If you notice, they're all straight edges and they're closed. Non-examples of polygons are these, because if you notice, they have curved sides, and you can't have that. So let's name the different polygons. A 3-sided polygon is a triangle. A 4-sided polygon is quadrilateral. Quad means 4, lateral means side. 4-sided is quadrilateral. 5-sided is a pentagon. 6-sided is a hexagon. 6 ends with an X, and hexagon also has an X, so 6, hexagon. 7-sided is a heptagon. 8-sided is an octagon. Think of an octopus. An octopus has 8 tentacles, so that's an octagon. A 9-sided polygon is a nonagon. and a 10 is a decagon. Think about a decade. 1 decade is 10 years. So a 10-sided polygon is a decagon. What's the difference of parallel lines and perpendicular lines? Parallel lines, if you look at parallel, even in the word parallel, these are lines that never intersect. The symbol for parallel lines looks like two lines going up and down, like this, almost looks like an 11. And if you look at the word parallel, you would see those two lines. Parallel lines never intersect. So if I look at line A and B here, these two never intersect. It could keep going on forever and never intersect, meaning it will never touch each other or cross over. Line X and Y are also parallel lines that will never intersect, even if I made those lines longer. So here I'm using the symbol. Line A is parallel to line B. Line X is parallel to line Y. That's what parallel is. Perpendicular is when lines intersect and form a right angle. A right angle is 90 degrees, and the symbol for perpendicular line looks like an upside down T. So let's look at this example. Remember, they have to form a 90-degree angle. So here are line 1 and line 2. They form a right angle. That means that line 1 and 2 are perpendicular, so line 1 is perpendicular to line 2. Now, the last important fact is important to remember the height is always perpendicular to the base. Height is always perpendicular to the base. Remember, this symbol represents perpendicular, and it actually, if you notice, it forms a right angle. So if I look at this triangle in A, this is the base and this is the height. The base always has to be a side of the polygon, and then the height has to be perpendicular to the base. So if I look at B, I know that this has to be the base because it has to be a side of the polygon and the height has to be perpendicular to it. It forms a right angle. Now, looking at this, these dotted lines means it's not an actual side. The solid line is a side. This bottom piece is the base. The height is perpendicular. The height, think about when you measure your height. You always take the highest part right above your head towards below where your feet are. So here's my triangle. The height has to match the height of the triangle down towards the bottom where the base is. Look at D. This is the base, this is the height. Now in D, the height is a side of the triangle. So this is the height and this is the base. And honestly, I could have called this the base. That means that this would be the height. And if you think about it, when you measure a person's height, could a person be laying down on a bed, let's say, and you measure their height? Yes. So sometimes your height can be, let's say, going across and your base could be going up. So now look at E. This triangle looks a little unique. The base is down here, and they measure the height up here. Honestly, I would have measured it over here from the top left towards the bottom and say that this is the height. But you could do it this way too. They're just showing you that it's the height of the highest part of the triangle to the lowest part, and it has to be perpendicular to the base. And F, this triangle, the base is down on the bottom, and the height is, again, perpendicular, forms a right angle. Now, this is called a parallelogram. This is the base, and the height is, again, perpendicular to the base. Now, this parallelogram, you're going to have to rotate your device. And if you notice, this is the base, and the height is the highest point to the lowest point. And this is called a trapezoid. A trapezoid actually has two bases. But it doesn't matter. Like this, both of them are bases. The reason why they're different is because they have different lengths. The height, remember, is always perpendicular to the base. And if you're ever confused looking at a trapezoid, which one's the base is, it's the two sides that are parallel to each other. So these two are not parallel. These two lines would eventually intersect. They can't be the base. The base has to be parallel to each other. Now, special triangles you need to know. Triangles are three-sided polygons. You can name them by their sides or angles. So we're going to name them by their sides. An equilateral triangle is a triangle with all congruent. Congruent means same sides and angles. So an equilateral triangle has all sides and angles that are the same. So if here are all sides the same, angles are the same. An isosceles triangle, a triangle with two sides and angles that are congruent. Congruent means the same. Isosceles. An easy way to remember is think about I saw with my two eyes, right? That you see with your two eyes. Isosceles. I saw with two eyes. So a triangle with two congruent sides and two congruent angles. So this side and this side are congruent and so are the bottom angles. Scalene triangle, a triangle with all different sides and angles. So if you notice, you see how this side has the 1 mark, right? This has 2 and this has 3. That means they have all different sides and the angles are also all different. This is a small angle. It's less than 90. It's acute, an acute angle. This is also less than 90, so it's also an acute. This is more than 90, so it's an obtuse angle. Now, special quadrilaterals you need to know. If you remember, I said quad means 4. So something for you to look at. Parallelograms. And I highlighted this. Feel free to highlight too. Parallelograms are quadrilaterals with two pairs of parallel sides. They have to be opposite sides that are parallel. An example of parallel are square, which is right here, rectangle, rhombus, and this is obviously a parallelogram. If I look at a rectangle, opposite sides are equal, and the inside angles are 90. So if I were to add the angles up, it has 390 times 4, which is 360. All quadrilaterals, even down here, all of them have 360 degrees inside. A square, all sides are equal or congruent, and again, 90 times 4 is 360. A parallelogram, opposite sides are equal like a rectangle, and opposite interior angles. Interior means the angles inside. So if you look, angle A, angle C, they're opposite, those are congruent. B and D, those are congruent. So opposite angles are congruent. A rhombus looks like a parallelogram except that all sides are equal, congruent like a square, but it's slanted, and opposite interior angles are equal. Next one, trapezoid. A trapezoid has one pair of, it's a quadrilateral, and opposite sides are parallel. And the two sides that are parallel are the bases. So side AD, side BC, those are the two bases. You can call one base 1, the other base 2. The height, again, would be perpendicular to the trapezoid. Now, a kite, two pairs of adjacent sides are equal. Adjacent means this next to each other. So you see how these two sides on top are adjacent next to each other? They're congruent. How the bottom two, they're next to each other, adjacent, they're congruent. This is a kite. And again, kite means next to. Now, what about finding the height and base of a quadrilateral? At this time, I want you to pause and see if you could fill out the next page. Okay, hopefully, I hope that you filled out the next page. If you didn't, pause again and then fill it out. But if you did pause, then I want you to check your answers. Finding the height and base of a quadrilateral and a triangle. Don't forget height has to be perpendicular to the base. So fill that out. Remember that height is always perpendicular to the base. Label H as height and B for base. So if I look at A, the bottom and top, those are the bases and the sides are the height. You don't have to label all around. You could just label one base, one height. This is for B. 9 yards is the base, 2 yards is the height. And again, I could have called 2 yards the base and then 9 yards the height, but I called it this one. Now look at C. This is the base, the 15. This I crossed out because remember the base and height have to be perpendicular to each other. So I don't need 11 yards for this problem. I'm just identifying base and height. This is called the side length. Now look at the This is D. It's a trapezoid. The two sides that are parallel have to be the bases. 4 is the height because it's perpendicular to the base. 5 meters is just a side length. I can cross it out. Eventually, you will need this. If, let's say, you're finding perimeter, you need to add the outside. But for now, we don't need this. This question is asking us to identify the base and the height. So look at E. 12 centimeters of base, 8 centimeters of height. Because they're perpendicular to each other, I cross these out. I don't need it for now, but I would need it for, let's say, perimeter. Now, F. You don't see an actual measurement, but we could count it. I know that this is the base, and the height is from the highest point down towards the base. It has to be perpendicular. Now, if I were to count the base here, I would start here. Count 1, 2, 3, 4, 5, 6. Since there's no label, this base would be 6 units. Now the height, if I were to count this, I would count from here. 1, 2, 3, 4, 4 units. And G, if I look at this triangle, this is the base. 1, 2, 3, 4 units. And the height would be from the highest point here. 1, 2, 3 units. So be careful. This almost looks like the same, but we count 1, 2, 3, 4, 4 units. Now look at this parallelogram. This is the base. I could have also called this the base, HG or GH and EF. So if I count 1, 2, 3, 4 units, and the height goes from the highest point to the base, 1, 2, 3 units. And lastly, this triangle. This is the base. Let's count 1, 2, 3, 4 units, and the height is the highest point towards the base, 1, 2, 3 units. I hope this video helped. Feel free to go back and watch this over. These are really important to know before we move into the Desmos lessons.